This is the atomic structure by Kevin Tam and Derek Ho.
We have the Bohr model, which includes the quantum model, which is the electrons in hydrogen atom that moves around the nucleus in circular orbits. The formula for this is E equals to negative 2.178 times 10 to the negative 18 joules. E stands for the energy level available to the electron in the hydrogen atom. N is the integer. The larger it is, the larger the orbit radius. Z equals to the nuclear charge, and J equals joules, which is a unit.
Another mechanical model is the quantum mechanical model. A standing wave is an electron bound to the nucleus. A wave function is a function that coordinates the electron position in a 3D space. An orbital is the same thing as m, which is a specific wave function. The Heisenberg uncertainty principle is the limitation of knowing the position and momentum of a particle at a given time. And this is the formula for it. And delta x is the uncertainty in a particle's position. And delta m nu is uncertainty in a particle's momentum. And h is Planck's constant, which is 6.6 times 10 to the negative 34 joules.
The probability distribution, which is the square of a wave function, indicates the electron probability near a point in space, or the electron density map. The radial probability distribution is the probability versus distance from nucleus.
Quantum numbers are a series of numbers that characterize orbitals. Principal quantum numbers are related to the size and energy of an orbital, symbolized by n, and n can be 1 to infinity. Angular momentum quantum numbers are related to the shape of the atomic orbital, that are symbolized by L equals to 0 and n minus 1. The magnetic quantum numbers are related to the orientation of the orbital in space, ML between L and negative L. The subshell is each of the orbitals given the value of L.
So here is a chart of how the this is the quantum numbers for the first 4 levels of orbitals in the hydrogen atom. There's N, L, the orbital designation, ML, and the number of orbitals.
The orbital shapes and energies. The nodal surfaces, or also known as nodes, are areas between energy levels. Degenerate is all orbitals with the same value of n, and they all have the same energy. Ground state is the lowest energy for an atom, and excited state is the higher energy state for an atom.
The electron spin and the Pauli principle. The electron spin quantum number is the two oppositely directed magnetic moments, plus half and negative half, symbolized by ms. The Pauli exclusion principle is the orbital that can hold only 2 electrons and must have opposite spin, therefore up and down.
Polyelectronic atoms are atoms that have more than one electron. Electron repulsions cannot be calculated exactly. This is known as the electron correlation problem. Electrons moving in a field of charge results in nuclear attraction and average repulsions of other electrons. Penetration effect causes an electron to attract to an s orbital stronger than a p orbital. And this is showing that the polyelectronic atoms are less in S and is in the gradius in D and F, and E is the energy of the orbital.
So now we have the off-ball principle, and no, not the off-ball principle, and the periodic table. The off-ball principle, as protons are added to nucleus, the electrons are added to orbitals, because protons and electrons are always with each other as a positive and a negative. The Hund's rule is the lowest energy configuration for an atom is having the maximum number of unpaired electrons with opposite spins. The valence electrons is the electrons in the outermost principal quantum level of an atom. Core electrons are the electrons in the innermost principal quantum level of atoms.
The Aufbau principle and the periodic table continued. Elements in the same group have the same valence electron configurations. That means the ones that go up and down. Transition metals are columns 3 to 12 between 2A and 3A ions in the periodic table. Lanthanide series are 14 elements after element 57 in the periodic table. Actinide series are 14 elements after element 89 in the periodic table. And the main group elements are alkali metals to noble gases, 1A to 8A, excluding transition metals.
So we have the periodic trends in the atomic properties. First one is the ionization energy, which is the energy required to remove an electron from an atom. Next is the first to infinite ionization energy. This is the energy required to remove the highest energy electron from an atom. As we go from left to right and up to down in the periodic table, the first ionization energy increases. Now we have the electron affinity. This is the energy change associated with adding an electron to an atom to produce an ion. The more negative the energy, the greater quantity of energy released.
Periodic trends in atomic properties continue. The atomic radii is the size of the atom, and covalent atomic radii is the distances between atoms in covalent bonds. Metallic radii are distances between metal atoms in solid metal crystals. The atomic radius increases from right to left and up to down. Francium has the largest atomic radius, and helium has the smallest atomic radius.
This is the AP Chem free response questions. The first part. Write the electron configurations of each species, sulfur and sulfide ion. Explain why the radius of the sulfide ion is larger than the radius of the S atom. Then, which of the two species would be attracted into a magnetic field? Explain.
The answer for A is the sulfur ion is 1s2, 2s2, 2p6, 3s2, 3p4. The sulfide ion is 1s2, 2s2, 2p6, 3s2, 3p6. The s2 minus has a larger radius than the s atom because two more electrons make the electron-electron repulsion have a greater distance, which makes the radius expand. The sulfur atom would be attracted into a magnetic field, and sulfur has two unpaired electrons, and it causes net attraction within the magnetic field.
Part B. The sulfide ion is isoelectronic with the argon atom. From which species, sulfide or argon, is it easier to remove an electron? Explain. In the H2S molecule, the HSH bond angle is close to 90 degrees. On the basis of this information, which atom orbital of the S atom are involved in bonding with the H atom?
The answer for part B is it is easier to remove an electron from the sulfide ion because the charge is not balanced. The sulfide ion has less attraction to the nucleus. The answer for C is the 3p orbitals are the atomic orbitals of the S atom, and the 3p orbitals are perpendicular to each other, which is 90 degrees.
Two types of intermolecular forces present in liquid H2S are the London dispersion forces and the dipole-dipole forces. Compare the strength of the London dispersion forces in liquid H2S to the strength of the London dispersion forces in liquid H2O. Explain. Then, do the same thing, just instead for the dipole-dipole forces in liquid H2S to the strength of the dipole-dipole forces in liquid H2O. Also explain.
The answer for D is the strength of the London dispersion forces in H2S is greater than the strength of the London dispersion forces in H2O because H2S has more electrons attracting each other. The strength of the dipole-dipole forces in H2S is weaker than the strength of the dipole-dipole forces in H2O because of the polarity of HS is less than the polarity of HO.
Here are the 5 multiple choice questions. Number 1. What is the maximum number of electrons in an atom with n equals 2? A. 8. B. 6. C. 100. D. 4. Or E. Too much information. F. Not enough information. The answer. The maximum number of electrons in an atom with n equals 2 is 8. Because there are 4 different orbitals, and when n equals 2, L can either equal to 0 or 1 according to the chart.
Number 2. What is the longhand electron configuration for silver? A. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d10. B. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d11. C. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d9. Or D. 1s2. E. Too much information. F. Not enough information. The answer is the longhand configuration for silver is AG is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s1, 4d10 because it is in the 5th row and silver is an exception to Hund's rule. So the 5s electron goes to the 4d orbital.
Number 3. Which element has the biggest atomic radius? A. Radon. B. Iodine. C. Selenium. D. Xenon. E. Not enough information. F. Too much information. The answer. The one with the biggest atomic radius is radon, because the atomic radar increases from right to left and up to down.
Number 4. What is the Heisenberg uncertainty principle? A. The limitation of knowing the position and momentum of a particle at a given time. B. Electrons in the outermost principal quantum level of an atom. C. As protons are added to the nucleus, electrons are added to orbitals. D. Series of numbers that characterize orbitals. Or E. Too much information. Or F. Not enough information. The answer for number 4 is the Heisenberg uncertainty principle is the limitation of knowing the position and momentum of a particle at a given time.
Last question. Which element has the greatest ionization energy? A. Neon. B. Fluorine. C. Hydrogen. D. Bromine. E. Too much information. Or F. Not enough information. The answer. The element with the greatest ionization energy is neon, because the ionization energy increases going left to right and up to down. That is our 5 multiple choice questions. That is also the end of the lecture. Have a nice day.